The following is an organic video short. This video discusses the conformational analysis of butane and focuses on how to write Newman projections. So let's get started. On the course website, you'll see that I've drawn a structure of butane in the hydrogen suppressed format. First carbon, second carbon, third carbon, and then fourth carbon. And then here in the three-dimensional portrayal, you can see the first carbon, the second carbon, the third, and the fourth. A Newman projection places one carbon. In this case, we're arbitrarily going to choose this second carbon as the front carbon and the third one as the back carbon. If we were to match that up with a three-dimensional structure, we could match it such that this is the second and this is the third. Fundamentally, what we are doing in a Newman projection, as I said, is placing one carbon in front of another. So here we've placed the front carbon in front of the back carbon. And when we look at it in this manner, we get sort of what you see here in the Newman projection. On the front carbon, we have a CH3 group coming off the top. And if you turn it, you can see that is coming indeed off the front carbon, and two hydrogens off the front coming down to the left and to the right. And in the back, staggered, we have a hydrogen and a second hydrogen. And in the 180 anti-degree position, we have the terminal methyl group. In order to compose a Newman structure from a 2D only structure, what you want to do is you want to define the front carbon and define the back carbon. Then simply list those substituents that are attached to the front carbon. Here we have obviously carbon back, a methyl group here, and two hydrogens. 1, 2. In the back carbon, we have the carbon in the front, a methyl group, a hydrogen, and a second hydrogen. Obviously, they're not shown as this is the hydrogen suppressed format. When you go to draw your Newman projection, you're then going to draw something like this. And on the front, you simply add the three substituents that do not include the back carbon. And on the back carbon, you simply add the three substituents and exclude the front carbon. And as you can see in the Newman projection, here we have a CH3, a hydrogen and a hydrogen, and on the back carbon, we have a CH3, a hydrogen, and a hydrogen. And then we simply rotate the front or the rear, but only one of them, in order to get the other conformations of the structure. Again, we're rotating around a single bond. Here we have the eclipsed conformation of butane. And you can see how this matches the Newman structure, the Newman projection rather. We pick again, one carbon as the front, the other as the back, and we line it up, put one superimposed over the other. You can see that the hydrogen in the front and the hydrogen in the back are indeed eclipsed. Oops. And the methyl groups on the bottom are also eclipsed. This is the highest energy, therefore the most unstable conformation of butane. And the last another major conformation is that of the gauche structure. Again, one in front, one in the back. You can see that the methyl group here to the left is 60 degrees between the methyl group on the bottom and a hydrogen here on the top. And that's how you do it.